solving this system by graphing. The graph is the answer to this. You're not going to get an ordered pair answer to this because it's inequalities. And inequalities, you're going to get more than one inequality that's a solution. So there's going to be like a solution area in the graph. So when we graph these, it's a lot like what we did yesterday, but it's not exactly the same because it's inequalities. You got the dotted line or the solid line. You've also got the shading involved. So as we graph each one, we're going to do all the steps for one problem and then go and do the same the steps for the second problem on the same coordinate plane. Okay, so for the first one, what form are each of those in? Slope-intercept form. They're in the right form for graphing. Just like yesterday, we needed them slope-intercept form. So there's a similarity with yesterday's stuff that they're in the slope-intercept form. So if I'm going to graph this first one, I'm going to use a blue pen to do that. What's the y-intercept of y is less than 3x minus 4? -4. So I'm going to go to -4 on the y-axis, put a dot. And then what's my slope? 3. +3. So I'm going up 3 over 1. Do that a couple of times. Once is enough, but a couple of times kind of helps get the line a little straighter. Then I have to look at it and decide, is it a dotted or solid line? Why is this one dotted? Doesn't have the equal to mark, so it's a dotted line. So I draw that line dotted. Then I have to shade that inequalities graph, okay? And the shading comes in to the test point idea. What point did I try to test a lot when we were doing this? 0, 0. The origin is always a good test point. If I plug 0, 0 into that inequality, is 0 less than -4? No, it's not. 0 is bigger than -4. So my shading would be away from the test point because 0 is not less than -4. So I would shade that side. And you can, with a pencil, just lightly shade that. I'm using a highlighter here because you can still see through it and see the grid because I still got to graph the other one there. So you just want to lightly shade that first one so that you can still see your grid and be able to graph the second one on the same coordinate plane. Okay, I used a highlighter there. You can actually use highlighters on paper, 2 different colored highlighters, and they'll mix together like this does. It's pretty neat. But let's graph the second one. What's the y-intercept of the second one? +2. What's the slope? -2 over 3. So I'll go down 2, right 3. Down 2, right 3. So do that a couple of times. Should this one be a dotted or a solid line? Why is it solid? Equal to mark on that inequality symbol. Makes it a solid line. Okay. And then I need to shade. Can I test 0, 0 again? As long as the line doesn't go through it, I can test it. Is 0 greater than 2? No. So that means I'm going to shade away from the test point because it was false. So I would shade above that line. So the solution area is this area where they overlap. This area. Okay. The solution area is where they overlap. If you're using a pencil, it'd be like, okay, I shaded this side, and then I shaded this side, and the solution area is where they overlap. There, you can see. Not always. No, sometimes if they might shade in opposite directions, and they be parallel lines, and they may never cross. The shading may never cross even. So it won't always be that. Most of the time with inequalities, you got a better chance of there being a solution area than you do with regular equations. Like that graph is the answer. That whole graph is the answer. Okay. And by that being the solution area, what that means is I could pick any ordered pair that's in this overlap region, and I could plug it in for x and y in both inequalities, and it'd be true in both of them. That's what the solution area means.
So will I let you put it on?
Yeah. Yeah, it's already got the grids on it. Yeah, so you won't have to draw them. Okay. Let's look at this one. X minus 2y is less than 6. And then x is less than 4. What's wrong with the first one? Not in slope-intercept form, so let's get it there. What do? Subtract the x, and that'll get us negative 2y is, nope, there's no equal to mark, is less than negative x plus 6. Divide by negative 2. And what happens when I divide by a negative with inequalities? Flip the symbol there to make it greater than. Negative 1x divided by negative 2 is positive 1/2 x. 6 divided by negative 2, negative 3. So this is our inequality that we're going to graph. This one and that one. Okay. Not much I need to do that second one. So go ahead and get our grid drawn here. What's the y-intercept for this green one here? Negative 3. Slope. So I do what? Up 1 over 2, up 1 over 2, up 1 over 2. Do that forever. Is it a dotted or solid? Why? No equal to sign, so that's a dotted line. Now we got to do our shading. Can I test 0, 0? Yes, the line doesn't go through it, so it makes it legal to test. So if I check 0, 0, is 0 greater than negative 3? Yes, so that means I shade the side that 0, 0 is on. This would be the top side. Make it clear that you're shading above that. You don't have to color it in real dark or anything like that. Now let's graph x is less than 4. What's that look like? Yeah, x in a number is going to be a vertical line. So I go to positive 4 on the x-axis, 1, 2, 3, 4, right there, and put a vertical line. Should that vertical line be dotted or solid? Dotted. Doesn't have an equal to mark, so it's dotted. And it says x is less than 4. Is less than 4 to the left or to the right? Left, because it's what numbers are less than 4? 3, 2, 1, 0. All of those are less than 4. So I'm going to shade to the left of that. Ooh. Big green solution area there. That overlap is where the solutions are. It really doesn't get much harder than this. It really is that pretty straightforward there. We're going to do one more. Okay. Not much harder than this, okay? Let's see. Let's say we had negative 4x plus 3y is greater than 0. And then we have 2y is less than or equal to 8. That's our system of inequalities to deal with. So what do we need to do to the first one? Yeah, get rid of the 4x by addition to get y by itself. That's get it slope-intercept form. So that's going to move us down to 3y is greater than 4x. Technically, it's 4x plus 0, but we don't have to write the plus 0. Now what? Divide by 3. Do I flip my symbol on this one? No, because I didn't divide by a negative. So it's y is greater than 4 over 3x. Okay, so there's that equation or inequality. Is this one ready to graph? Not quite. Let's get it ready to graph. What do? Divide by 2, and that's it. So that's y is less than or equal to 4. So those two are the ones that are boxed in, are the ones we're graphing. Okay, so let's go graph them. Let's graph the green one first. Y is less than or equal to 4. What do I do? What kind of this way? Dotted or solid? Solid horizontal line. Solid because it has equal to mark. Okay. And then it says y is less than or equal to -4. Y is less than or equal to 4. Would less than be below that or above that? Below. Less than is below. So we're going to shade below that. Again, just lightly shade that so you can still see your grid, because you got a whole other inequality to graph here. That's what it was. All right. Now let's graph the red one there. 4/3x. What's the y-intercept? It's 0. When there's not anything out there, it's 0. So we're going to start at 0, 0, which is going to mess up our testing, but we can figure out something else to do, I think. What do I do from there? Up 4/3. Dotted or solid? Dotted. I can't test with 0, 0 because the line goes through it. Well, I can't just test with the one number. I've got to have two numbers. I've got to have an x and a y. 1, 1. Yeah, the graph barely misses 1, 1. So that works. Is 1 greater than 4/3? No, it is not. So I'm going to shade above that line, which would be this direction. So we have the solution area there. And JC, can it get any more complicated than that? The only thing that could happen here is that you have more than two to graph on the same coordinate plane. You're not going to see that much in Algebra 1. That's more of like an Algebra 2 type thing where we do this thing called linear programming. You have like 4 or 5 of them to graph, and then you make a shape, and then you do some work with that shape. But that's all based on graphing inequalities just like this. Okay, so it doesn't get any more complicated than that. It really is that straightforward. All right.